Alright, let's look at the practice exam 2, problem number 10. Right, so we want to change the order of integration to evaluate this double integral. Right, so looks like this integral in this order is going to be pretty difficult, so we're going to switch the order of integration. Alright, so first we have to know the region we're integrating over. Right, so notice that here we are doing with respect to x. So these are x values. So x equals y and x equals 3. And this is going to be a y value. So y equals 0 to y equals 3. Alright, so let's sketch the picture. Alright, so I'm going to draw y-axis and x-axis. Alright, and x equals y is just going to be a straight line, so I'm going to just draw that. Let's see, so it's a 45-degree line, so x equals y or y equals x. Right, x equals y. Alright, then goes to x equals 3. Right, so x is going to equal to 3. So let's see, 3 is going to be somewhere, I'll say somewhere around here. Right, so x equals 3 is this vertical line at 3. Right, so this is x equals 3. Right. Then let's see, y goes from 0 to 3. So this is 3 right here. Right, so this is 3. So 0 to 3. So we're looking at y equals 0 is right here. Right. So we're looking at this triangular region right here. Alright, so we want to switch the order of integration, so this is going to be a double integral. Right, and it's still the same function, so square root of 9 minus x squared. But we're going to do the integration with respect to y first, then with respect to x. Right, so we're going to fix the x value because we're going to do the with respect to y first. So fix the x value, say somewhere on here, and it looks like starting from y equals 0 all the way to this straight line, y equals x. Right, so we can set it up as, let's see, y equals 0 to y equals x. Alright, then after that, to swipe the same triangular region, looks like x is going to start from 0, then keep covering, and all the way to x equals 3. Right, so it's going to go from 0 to 3. Alright, so let's evaluate this. Since this has nothing to do with y, so this is a constant. Right, so I'm going to place it in front of the integral. Right, so you're going to get outer integral from 0 to 3. Right, so we have square root of 9 minus x squared is outside. So once you pull that out, you basically have 1. So antiderivative 1 would be y. And y is going from 0 to x. Right? And you can see that that's going to give you x, right? X minus 0. So this is going to be just x. Right? So let's do a substitution. I'm going to let u be the expression inside the square root, inside square root. So you have 9 minus x squared. So I'm going to call this guy u. Alright, and then goes through the usual drills. Take the derivative of u with respect to x is going to be negative 2x. Right, and then take the reciprocal of both sides. So you have a dx over du, which is equal to 1 over negative 2x. Right, then we can just divide through by du to get dx is equal to du over negative 2x. Right, and also we have to change the lower limit and upper limit. So x is actually x goes from 0 to 3, right, which means that u is going to go from, right, put 0 there, so it's going to be 9, to put 3 there, 9 minus 3 squared, so that's 0. Right, so this integral can be rewritten as integral from 9 to 0, and the square root of u, so I don't, let's see, maybe I'm going to write the square root of u like that. Alright, so this is, I'm going to leave this x as it is for now. Alright, dx is the same thing as du over negative 2x. Alright, so we can cancel x on top and x on the bottom. Right, and also I'm going to actually use this negative sign to switch the lower limit and the upper limit, because I like to go from 0 to 9 instead of 9 to 0. So I'm going to use that to change that to 0 and change that to 9. Alright, then I have so 1/2 right here. I'm going to place it in front of the integral. Right, so we can write it as, right, 1/2 is just a constant. Then you have an integral from 0 to 9. Right, square root, I don't like square root, so I'm going to write u to the 1/2 power, and then you have a du. Right, then we can take the antiderivative, so you're going to get 1/2. Right, antiderivative u to the 1/2 would be, and add 1 to the power, so u to the 3/2 power, and divide by 3/2 is same thing as multiply by 2/3. Right, so we do that, and then you're going from 0 to 9. Right, so you can cancel 2 on top and 2 on the bottom, and pull out 1/3. So I'm gonna actually go up here. Alright, so it's going to be 1/3. I'm going to just a constant, it's outside. Alright, and you put 9 to the 3/2 power. So let's say 9 to the 3/2 power. Alright, so what's that? 9, so 1/2 power would be square root of 9, which is 3. And it's a 3 cubed. So, but there's a 3 here, 3 squared. So this is going to be just 9. Alright, minus 0 anyway. So 9 is the value of this double integral. Alright, that's it. I hope that this was clear.